Here we go, guys. Example number 11 under linear functions. This will be the last one that we'll enjoy together for this assignment. You're going to do great. So here's the deal. We have a person who purchased a car, and 4 years later, it had fallen in value. And the point is, the value of the car and the age of the car would be related. And it turns out in this case that we're going to build what would be called the straight line depreciation. Actually, this is something they do in business, I'm told. At least when I took accounting 1,000 years ago, let's just say in the previous millennium at Emporia State University, I remember in an accounting class, we talked about what's called straight line depreciation. And that's exactly what's happening here. So we're going to build the equation of the line that relates the age of the car to its value. I would say age would be years and value would be dollars. Years and dollars would be the two variables. And here we go again. When you figure this out, y per x, y per x. Can you hear me? Per. All right. So here we go. Which one makes sense to you? Dollars per year. Option number one, dollars per year, or years per dollar. Well, I think dollars per year makes sense there. I agree with you. I'm so proud of you guys. Yes, dollars per year. So y per x, I think y should be the dollars and x should be the years, right? So value of the car, age of the car. Awesome. Okay, now on the previous example about shoes, we talked about look for the word per, and if it's there, maybe that's your slope. But as you read the narrative, I don't think that's the case here. So I believe what's happening, if you think about it, would be that they're giving us a couple of ordered pairs this time. Because in that first sentence, they're saying that the value of the car was $15,837, which would be a Y value the way we're setting it up. And the question becomes, how many years old is a car when it's brand new? Yes, 0. So, when the car was 0 years old, it was worth $15,837, and that would be in the language of algebra, x1, y1, wouldn't it? That would be an ordered pair. See, they didn't give us a per this time, did they? All right, and if we keep reading, the second sentence then says, 4 years later, it was worth $9,425. And wouldn't that be an x2, y2? So I'm thinking the logic on this one would be more along the lines, two ordered pairs, wouldn't it? That's what's happening here. And so you got to read the question and figure out what information is given to you. So I think we'll find our slope this time with the definition that we did on assignment 18, as in y2 minus y1 over x2 minus x1. I can do 4 minus 0 in my head, that's 4. And then 9425 minus 15837, I'm sure I could figure that out if I thought long enough, but my brain kind of hurts right now. So negative 6412. Okay, here's what happened. Remember, the numerator of a slope is y, and the denominator is x. It looks like this thing dropped in value, $6,412, over the course of the 4 years. And then if we divide that, actually, negative divided by positive is negative, and if we divide that out, that's negative 1603. Okay? Now, slopes, again, in my opinion, are easily understood, easily interpreted, if we change them into fractions. So what's negative 1603 in fraction form? Over 1! That's right. Now look, what's this? That car is losing $1,603 of value per fraction bar for every 1 year. And that goes in right here. Now, I remember back to that accounting class at Emporia State University in the previous millennium, they said that that would be called what? Annual depreciation. Depreciating per year. Annual. For every 1 year, it's losing that much value. That's called annual depreciation according to the business people. Right? Okay. So there's overlap. between these disciplines if you pay attention. All right. How do we find B? Let's plug numbers in. We just figured out that the value of M is negative 1603. We're looking for B. Let's pick an ordered pair. All right, now, I'm gonna do something dumb. It won't be the first or the last time. We could actually pick either ordered pair there, and I think the 0 would be the smarter choice. But let's just say, I don't know, I'm gonna pick this one. And I'm doing this for a reason. But if you put 4 in for X and 94.25 in for Y, you know, it still works. Not a wise choice, I'm telling you, I know this, but it still works. And it's not the first bad decision I've made in my life, all right? But anyway, you multiply these two and get negative 6412, and then we add the 6412 over, you know, arithmetic, right? Multiply it, move it over. And when you add that over, it's 15,837. And you put that in here. And you might think, well, that number sounds familiar, 15,837. Well, I know, look. Didn't we say that that number sticking on the end would always correspond to the B, the ordered pair 0, comma, that number sticking on the end? If I'd have been paying attention, and I pretended not to, but that ordered pair over there actually would have been the B value, wouldn't it? It's the beginning, oh, it's the beginning value of the car. Beginning point, beginning value. Ah, so if you're lucky enough to have an ordered pair 0 something, that really would be your B value. And you wouldn't have had to have done this if you'd have been paying attention. But oh well, it still worked, right? Sometimes you can not pay attention and you still get away with it. Are you guys still awake? All right. So anyway, there's that. And now we go on to part B. And part B simply says, all right, you got your mathematical model. That's called straight line depreciation. I don't know if the IRS still allows companies to use just straight line depreciation. I bet they do in certain cases. But anyway, the question now would be, what would be the value of the car when it's 7 years old? And you simply say, well, I built my equation. Now I'm going to use it. I'm going to enjoy it. I'm going to put 7 in for X and see what this would project the value of that car to be when it's 7 years old. So negative 1603 times 7 plus the 15,837. And this again would be using what the business people call straight line depreciation. And it looks like in year 7, they would say that that car would be $46.16. Let's put the dollars on it. So, yes, you'll have a question or two on a quiz, assignment 19, where maybe we give you 2 observations, 2 ordered pairs, and you logic your way through it like that, okay? So that's it on linear, and I think we're done with this assignment, so good luck on assignment 19, and please get that to me at your earliest convenience. Let's try to stay on pace. All right, awesome. Thank you, guys.